Hi, in this tutorial, we're going to be covering slopes. In this tutorial, you'll learn how to compute a line slope, how to use the slope to show that lines are parallel, how to use the slope to show that lines are perpendicular, and how to calculate the rate of change in applied situations. Now, a slope measures the steepness of a line. So the slope compares the vertical change, which is the rise, and has the equation y2 minus y1, so this point minus y1, to the horizontal change, which is called the run, and has the equation x2 minus x1. So the slope is the change in y over the change in x, or the rise over run, or the equation y2 minus y1 divided by x2 minus x1. Now let's talk about some possibilities for a line slope. Now if the slope is positive, then the line rises from the left to the right. So here notice that the slope rises from left to right in this direction. Now when the slope is negative, the line falls from left to right. Notice that the line is falling from left to right. So it goes in this direction when the slope is negative. Now the slope of a horizontal line is 0 because it is not rising or falling. So when a line goes through the y-axis, its slope is 0. Now the slope of a vertical line is undefined. So when a slope just goes through the x-axis, it does not have a slope. It is undefined. Now let's talk about slope and parallel lines. If two non-vertical lines have the same slope, then the lines are parallel. Notice that this blue line has a slope of 2, and this yellow line also has a slope of 2. That means that these two lines are parallel. Now, let's talk about slope and perpendicular lines. If the product of the slopes of the two lines is -1, then the lines are perpendicular. Notice that this blue line has a slope of -1/2, and that this yellow line has a slope of 2. Now when you multiply them and their products equal -1, so here it equals -1, then that means that these two lines are perpendicular. Now the slope, let's talk about the slope as the rate of change. The slope of a line represents its rate of change. It tells you how fast y is changing, so how fast you're going up or down with respect to x. So depending on how far you go from x, y will also change. It'll tell you how fast y is changing. So let's do an example. Let's find the slope of the line passing through the points. So here, this point is -1 and 2. And this point is 2, -2. So now remember, the slope is the rise over the run. So we have rise over run, which is equal to y2 minus y1 over x2 minus x1. So here y2 is here, -2, minus y1 is here, 2, over x2 is 2, minus x1 is -1. So all we have to do is compute this. So -2 minus 2 is, let's write that here, -2 minus 2 equals -2 plus -2 equals -4. Now let's do the bottom. We have 2 minus -1, or 2 plus 1 equals 3. So our slope is this rise over this run. So it would be -4 over 3. So that's our slope. N equals -4 over 3. So in this tutorial, you learned how to compute a line slope, how to use the slope to show that lines are parallel, how to use the slope to show that lines are perpendicular, and how to calculate the rate of change in applied situations. Now try and solve the problems in the slope workbook. For more help, sign up for online tutoring. And in the next tutorial, we're going to be covering the slope-intercept form of the equation of a line. Thank you.